Today we're going to be learning about our last situation of factoring, which is factoring differences of squares. Before we get to the actual factoring, I want to refresh our memories of how we multiply when we have a sum times a difference with the same number. So we would multiply just like normal, everything in the first parentheses times everything in the second parentheses. Then I combine what's in common, which is the x's. I have negative 5x's and positive 5x's, which would leave me with no x's left. So this would just be x squared minus 25. So today what we're going to be doing is starting off with the x squared minus 25 and thinking about how we would get back to this original multiplication problem. Well, whenever we have a difference of squares, meaning we have one term squared and another term squared, and it's a difference, meaning we are subtracting them, then we know that it's going to follow this pattern of this was the original multiplication problem. So if I were given x squared minus 25, in the first parentheses, I'm going to put this first term, the square root. So the square root of x squared would just be x, plus the square root of the second term, square root of 25 is 5. And then to make it a minus 25 and to cancel out these middle terms, I need to do the opposite. So instead of plus 5, I will do x minus 5. And so this would be the factored version of this polynomial here. So just a couple quick notes. The factoring of difference of squares works only if you have subtraction. If we had something like this, x squared plus 25, that does not work, because in order for the middle term with the x to cancel, we need one to be plus and one to be minus. So in the end, it would multiply to equal a negative number. So if we have a positive number, we can't follow this pattern here. If you had something like this, this would be a prime polynomial. But if we have a difference of squares, it's a subtraction problem, then you can follow this pattern. One more example I want to show you is, again, we have a difference of squares, but now we also have a coefficient next to the x squared. If this coefficient is also a square number, we follow the same pattern. So in the first parentheses, I'll put the square root of this first term. So I'll start with a number, the coefficient 16, square root of that is 4, and then the square root of x squared would just be x. Then plus the square root of 81 is 9. Then in the second parentheses, I put the same thing, but this time minus. So that way the middle term would cancel out. So this is the factored form of this difference of squares here. So then on your notes page, there are these 4 problems. This one I just solved for you right now. So hopefully you have this answer. Then go ahead and solve these other 3 when you are done. So pause the video, solve them. When you're done, play the video to check your answers. I'm going to be checking that you have these complete. So these are the answers that you should have had. Couple quick things I want to highlight. If the number and the variable are switched, that's okay, because both of these are still squares. So we'd follow the same pattern. The square root of 64 goes first, then the square root of m squared goes next. So it would look like this. Here we have different variables, but same pattern. Square root of 25x squared is 5x. Square root of 49y squared is 7y. And these would be your answers to that. Now we're going to look at some examples where we have a difference, but these numbers are not squares. So we're going to start off the same way we've started since the very beginning when we first started factoring, by seeing, is there a common number that can be divided into each one of these? 8 and 32? Yep, these can both be divided by 8 is the biggest number that both can be divided by, and that is the only thing in common in these two terms. So that is all I'm going to take out of the parentheses. I'm left with 1y squared, or just y squared, minus 32 divided by 8, 4. So now we have inside this parentheses, we can check to see if this can be factored anymore. Well, we have a difference of 2 squares. So inside this parentheses, this can be factored following the pattern of a difference of squares. This 8 will stay the same. On the outside, it won't change. And then y squared minus 4, factoring, the square root of y squared is y, square root of 4 is 2. So y plus 2, y minus 2. And this is the factored, completely factored form of this polynomial. Here are now the last 4 problems on your notes page. So you can again pause the video to solve them. And when you're done, play the video to check your answers. Again, I'll be checking to make sure these are complete. So these are the 4 answers that you should have gotten. A couple things I wanted to highlight on here. In this third problem, not only could they both be divided by 9, but they also both had a y in common. So before I did anything else, I factored out a 9 and a y, and then I factored what was left there. 1 is a square number. The square root of 1 is 1, so that's how I got these numbers. Then in the fourth problem, not only could they both be divided by 3, but here we have 4 x's and here we have 2 x's. So I want to take out as many x's as possible that are in common. So we could take out the most number of x's we could take out of both of these would be 2 x's. So I took out the 2 x's and then I factored what was left to get that. If you're still a little bit unsure on how I got any of these or any earlier ones or the process we follow, please let me know what questions you have as you are working on the homework assignment posted on Google Classroom.